Everyone, and I welcome you all to today's video. Today we are going to understand several different concepts of data science and machine learning, like supervised and unsupervised learning, and parametric and non-parametric models. We are also going to look at some of the classification metrics which are used for evaluation of models. So let's start. We are going to understand these topics by solving certain question of end semester question paper. My name is Manas Pathak and I'm a student of IIPS DAVV. So let's start. So the question for today is differentiate between the parametric and non-parametric models and supervised and unsupervised learning. And the second part is with respect to text mining, describe accuracy, precision, recall, F1 score and illustrate the computation using confusion metrics. So let's solve each part of this question one by one. First, let's see the differences between the parametric and non-parametric models. Parametric model. So it takes strong assumptions about the data distribution and relationship. Example, linear regression assumes linearity. So, for a parametric model, it makes several strong assumptions about the data which is given to the model. We can understand it by the example of linear regression, that a linear regression model would assume that there is a linear relationship between the independent and dependent variables of the data. So it forms certain parameters to define that linear relationship accordingly, and it all the processing is done based on these parameters which it has assumed to exist for the given data. So that is why the parametric models does is they build a model, and based on that model they define certain parameters for which they find the value, and all the processing is done based on these parameters which are decided by the model. Hence these parameters indicate the strong assumptions about the data, and all the processing is done based on these parameters. Hence it gets its name parametric model. While the non-parametric model, there are fewer assumptions about the data distribution and relationships. So in non-parametric model, there isn't much building of a model. Like for example, one of its example is k nearest neighbor. So in k nearest neighbor, there is no training phase. Hence there is no model building done generally for non-parametric models. So since there is no building of certain model, there are no certain parameters which are defined for the given data, and there is no processing done based on certain parameters. Hence it gains the name non-parametric models. Flexibility. The parametric models have limited flexibility due to limited functional form, because much of the processing and much of the steps in the building of the model or in the prediction for a given data point, the processing is done based on the decided parameters. Hence all the processing is done in accordance with those parameters. Therefore there is limited flexibility. Whereas in non-parametric models, there are not any such parameters that exist. Hence it gives you high flexibility to model complex relationships. Interpretability. The parameters have clear interpretations, because once we have calculated the parameters for parametric models, then they can be clearly interpreted, and we can draw clear conclusions based on the values of those parameters. And since in non-parametric models there aren't any such parameters, or very few parameters which are being used, so they are less interpretable, but it focuses on the predictive accuracy. So the main focus of the non-parametric models is not to build certain parameters which are clearly interpretable, but it focuses on the predictive accuracy. Computational efficiency. Parametric models are generally more computationally efficient, whereas the non-parametric models can be computationally intensive, especially with the large data sets. The data requirements. Less data is required for parameter estimation, whereas more data is needed for accurate modeling of complex patterns. So since in parametric models we have already defined certain parameters, therefore we can also work, we have already defined that certain parameters should exist. We can also work with less amount of parameters, whereas in non-parametric models, since we have not clear defined a pre-assumed relationship between the data variables, we need more data to accurately understand the data and make accurate predictions. For computational efficiency, I would also like to add that the parametric models are more computationally efficient, because once we have found the values of parameters, we just have to put for linear regression, if I have already defined the value of a and b, which are my two parameters for a linear relationship, then for each incoming new data point, I have just to put the value of that data point into the predefined equation which I have made to get the prediction or the result. So it makes the parametric models more computationally efficient, whereas for each new data query which is for prediction which is presented to the non-parametric model, it has to make several computations based on the data it has memorized or saved into its memory. That is why non-parametric models become more computationally intensive. And what is the difference between supervised and unsupervised learning? For supervised learning, input data is a labeled data where input features are mapped with their corresponding outputs. While in unsupervised learning, it uses only unlabeled data, that is the data only in which there are only input features and it doesn't require any outputs. The goal of supervised learning is to predict outcomes or classify data based on known labels, whereas the goal for unsupervised learning is to discover the hidden patterns, structures, or groupings in the data. The computational complexity for supervised learning is less complex because we already have a labeled data, so it provides a clear guidance to the algorithm. Whereas in unsupervised learning, since there is no labeled data, there is not enough guidance, hence there is more computational complexity. There are two types of supervised learning problems. One where we have to classify certain discrete tuples into an output. We have to basically classify input tuples into outputs into certain classes, which is called classification. And the other type of problems in supervised learning is to predict certain numerical values, which is regression. Whereas in unsupervised learning, there are two types of problems. One where we have to form clusters, and other where we have to find association between elements. For testing the model in supervised learning, we can easily test our models because we already have a labeled data. So we have the input and we have the correct output. So we can match the correct output with the predicted output of the model to test our model. Whereas in unsupervised learning, since there is no labeled output with us, so there aren't much testing methods, hence we cannot test the model in the traditional sense, as there are no labels. So now let's first look at the accuracy, precision and recall, and how accurate precision and recall are more are of importance than accuracy with certain example. Accuracy is a classification metric. It is a ratio of total correct predictions to total number of predictions. Higher the accuracy, better the model. It is also called recognition rate. So accuracy is the one of the most basic type of classification metric, which is just simple ratio of correct predictions to total number of predictions. We can also find the percentage of accuracy by multiplying the accuracy of value by 100. So accuracy is not considered at all times in classification problems as a metric, because there are several aspects of the classifications or the predictions done by the model which are of which must be highlighted, or which are of much importance given upon the problem which we are dealing with. And these aspects are not properly addressed by the accuracy. It just addresses the correct predictions, but at times we would also want to know that how many are the false positives or the false negatives encountered in the classification process by the given model. So for that, precision and recall come into the play. Precision, it is also called measure of exactness. It is the ratio of true positives to total predicted positives. It is crucial where consequence of false positive is high. It is preferred metric for labeling patients as cancerous and non-cancerous. So precision particularly focuses on false positive positives, where it is used in the situations where the consequence of a false positive would be higher. For example, while labeling patients as cancerous and non-cancerous, a false positive would bear a higher consequence, as a false positive would indicate a non-cancerous patient labeled as cancerous. So in this case, if a non-cancerous patient is labeled as cancerous, and if we start with the therapy like chemotherapy and other therapies of cancer for that patient, then it would they might cause to the side effects to the healthy patient, and would also bear the financial burden on that patient, which we must avoid. Hence, precision is an important metric here, which focuses on the consequence of false positive and tries to, and we try to minimize the false number, or the number of false positive in the classifications done by our model based on the value of precision. Hence, we try to maximize the value of precision. Recall or sensitivity. It is also called measure of completeness. It is ratio of true positives to total actual positives. It is crucial where consequence of false negative is high. It is preferred metric while predicting tsunami. So again, while precision focuses upon the false positive, the recall or sensitivity focuses on the consequence of false negatives. For example, in a prediction of a tsunami, a false negative would be a coming tsunami labeled as not a threat or not coming. It would be a false negative. In such case, a false negative bears a very higher consequence, as the people of that area won't be alarmed for a coming tsunami. Hence, there would be increased death toll due to the tsunami, and there would be no preparation. So this is one of the case where the consequence of the false negative is high. So recall, by the value of recall, we try to maximize the recall value, hence minimizing the false negatives in the classification. Therefore, precision and recall become the metrics of importance in such cases. And in such cases, we won't be focusing much on the accuracy, as the precision and recall are more important ones to address. So this was the importance of precision and recall over accuracy. Now let's calculate the accuracy, precision and recall for a given confusion matrix. So this is my given confusion matrix. Let us first identify the different classes from this matrix. The true positives are the positives predicted as positives. The value is 6. False positives are the negatives predicted as positives. It is also known as type 1 error. Its value is 2. False negatives are the positives predicted as negative. It is also known as type 2 error. Its value is 4. And true negatives are negatives predicted as negative. Its value is 8. The formula for accuracy is TP plus TN divided by TP plus TN plus FP plus FN, which is basically the total predictions done by the model. Substituting the values in the formula, we get the value of accuracy as 0.7. Precision. The formula for precision is true positives divided by true positives plus false positive, which are basically total predicted positives. Substituting the values, we get the value of precision as 0.75. Recall, the formula for recall is true positives divided by true positives plus false negative. Substituting the values in the formula, we get the value of recall as 0.6. The true positive plus false negative indicates the total actual positives in our data. So this was the formula for calculation of accuracy, precision and recall. Now let's move on to the next. Next is F1 score. F1 score is a performance metric used in machine learning to evaluate how well a classification model performs on dataset, especially when classes are imbalanced, meaning one class appears much more frequently than other. It is harmonic mean of precision and recall, which combines both metrics into a single value that balances their importance. So F1 score basically comes into play when we have to analyze both precision and recall together, and these two metrics vary from each other to a greater extent due to imbalance of classes. Hence, F1 score, what F1 score does is it brings both of them together so they can be studied together, and it balances their both of their values, combines them into a single metric and balances their values so that we could have proper and easy interpretations for both of the metrics. So it combines the two important metrics, which are precision and recall. So the formula for F1 score is 2 into precision into recall divided by precision plus recall. Substituting the values into the formula, we get the value of F1 score is 0.6667. One more thing about the F1 score is that in F1 score we use harmonic mean instead of the normal arithmetic mean here, because the harmonic mean balances the two metrics better than how they are balanced by the arithmetic mean. So this was all about today's video. I hope you learned something from here. If yes, then please consider liking this video and subscribing to my channel, and I'll see you in next video. Thank you.